Diagnosis for many neurological disorders and conditions can be confirmed only through autopsy. So postmortem brain tissue from individuals afflicted with these and other neurological disorders and conditions is a highly sought after resource.
Just in the example of traumatic brain injury, there have been 31 trials trying to take compounds that have shown benefit in animal models and translated to human trials. All of them had failed, all 31 of them, and that's the total sum of the trials that have been done. 31 out of 31 have failed. There is no way to get at the details of what that translatable component would be other than through identification of cells or tissue systems and samples of cells or the physiology of the tissue. But again, in order to do that, we need to start with the characterization in humans, in models, and then reverse engineer it to the appropriate models for which we need tissue to bridge that gap. So we need to identify the deviation from brain health much, much earlier to be able to really have an impact. I believe that it's more likely that we will prevent Alzheimer's disease than that we will cure it.
CTE begins with chronic inflammation, then primarily as a tauopathy. As they're getting older, it begins to recruit other proteinopathies, including amyloid. And when you look at the brain, I looked at the brain of a 90-year-old professional boxer. It looked almost like Alzheimer's disease. By the time you begin to have accumulations of the abnormal proteins, the damage is done. So we need to go back as far back as possible. And you can tell all these things. Why I've succeeded, really, was because I had access to brains. I had hardcore, indisputable physical evidence. The laws that establish the autopsy actually state that the autopsy is a tool for the advancement of medical science.
You really need large, not just human tissue, but large numbers. There was a paper recently, for example, that looked at brain expression of various genes in the brains of schizophrenics. There have been many previous publications that have been done using 20, 30 brains. This paper looked at hundreds of brains, and many of those original studies, the conclusions turned out to be fallacious, that there simply was not the power to reach conclusion. So I should say, we want actually people alive. We also would like their brains afterwards. I mean, we need people alive because we need to know as much about their function as possible to be able to test hypotheses. We think animal models are spectacular for sort of developing hypotheses. There are very specific things that one can do with human material to see to what extent do the very specific models you've developed in animals apply to humans. My own view is that we need brains. We use living brains for everything that technology lets us do with living brains. But there's a level of anatomy and analysis which is now possible, both in terms of fine synaptic and connection structure, gene expression and studies and so on, where technology's made incredible advances, where one simply needs large amounts of postmortem material from a wide range of different individuals. Actually, standardization of how material is collected and preserved is a major issue. That brains can only be shared productively when they've all been collected and stored in the same way. And this is an ongoing scientific discussion. How do you best treat this valuable material in a way that it's most useful for a wide variety of technologies now available and that may become available in the future?
I think that the social and the modern day popular aspects of CTE has led to really an explosion in the public's perception of why we need tissue, why we would need an organ such as the brain, which for many of the public, they never really appreciated why the brain could be very important after death for us to learn. And as we in the mid-'80s looked to doing organ transplantation and particularly dopamine-containing cells for Parkinson's, which really has followed a storied evolution. There are many, many aspects which make this very exciting times, and hopefully this will continue to grow in interest and appreciation by the public.
But when you suffer a concussion, and I look at your brain microscopically, you suffer vascular injury, axonal injury, and membrane injury. There is nothing mild about a concussion. Radiologically, your brain may appear normal, but on the cellular level, so we have a long way to go, and tissue analysis plays a critical role. We may never have all the answers, but the absence of answers does not mean denial of a fact.